Welcome again, dear friends, in the online lecture series on thermodynamics. In the last lecture, we have discussed about state, path, and process, and in this lecture, we will discuss about quasi-static process. So, in this lecture, we will discuss about quasi-static process. So, let's begin the lecture. As we already know, changing of system state from one equilibrium state to another is known as process, and the series of states through which a system passes during a process is called path of the process. So to define the path, we require the series of states. However, the identification of series of states is not an easy task. To define state, system must be in equilibrium. It means there should no unbalanced force within the system. We have already discussed the meaning of equilibrium in our previous lecture, and we will also discuss little about equilibrium in this lecture. So let's understand why identification of series of states is not an easy task with the help of example. Let's consider a piston cylinder arrangement in which some gas is filled. The piston is at BDC and the gas is in compressed form due to this weight W on the piston. It means the gas has high pressure and low volume. We can also represent the state of the gas on the PV diagram. So on the PV diagram, the state of the gas will be lie here. So it has high pressure and low volume. Since the gas is in compressed form, the molecules of the gas are closely packed. So these are the molecules of the gas which are closely packed. If we remove this weight W from the piston will move upward and the gas molecules will also move upward with piston. However, the molecules which are close to piston will reach to TDC immediately with piston, and the molecules which are away from the piston will take some time to redistribute. So let's remove the weight. So we can see molecules which were near to piston moves towards the TDC, and molecules which are away from the piston are still closely packed. So there is a pressure difference within the system. It means the system is not in equilibrium, and we cannot define the system state at this instant. However, with time, molecules will redistribute and system reach to its final state. So at this state, system has pressure P2 and volume V2. So in this way, process is completed as system change its state from one equilibrium state to another equilibrium state. However, we cannot identify intermediate states as the properties are kept on changing within the system and system is not in equilibrium. This process path can be like this or maybe like this. So we are not able to define the path of this process. For the path, system must be passed through series of equilibrium states. When we remove this weight W, piston moves upward very quickly and system lost their equilibrium. If we divide this weight W into n number of small weights and remove these weights one by one, so that properties in one part of the system do not change any faster than those at other parts, then we can find the path for the process. So when we remove the single weight, gas will expand and its volume increase, and due to expansion, pressure will be decreased. However, the change in volume and pressure are too small and they are tends to 0, so that system reach to equilibrium quickly. If we remove these weights continuously, we will get series of states through which system pass during the process, and we can also define the path for this process. A process which proceeds very slowly so that system passes through series of equilibrium state is known as a quasi-static process. For quasi-static process must be very slow so that the dragging force of the process always tends to 0. A quasi-static process can also be defined as a sufficiently slow process that allows the system to adjust itself internally so that properties in one part of the system do not change any faster than those at other parts. So when a process proceeds in such a manner that system remain infinitesimally close to an equilibrium state at all the time, it is called a quasi-static process. So in the quasi-static process, system always remain in the equilibrium state. Quasi-static process is an idealized process which is used for ease in thermodynamic analysis. So in actual life, no process is such slow as quasi-static. However, for ease in analysis, we assume process occur in quasi-static manner. For a non-quasi-static process, we are not able to define process path for the system. So if process is not quasi-static, we cannot define the path. Hence, for the quasi-static process, path is defined by dashed line instead of solid line. So if we want to define the path of a process, process must be quasi-static. If the process is not quasi-static, we cannot define the path of the process. So this is all for this lecture. Thank you.